Now we will see set. Set is nothing but a collection of elements. A set is nothing but an collection of elements. Collection of an elements. For example, n is nothing but 2, 4, 6, 8, 10, 12 and so on. These are a collection of elements which are divisible by 2. This can also be written as x such that x is nothing but 2k, k greater than or equivalent to 1. One is a roster form, another is a set builder form. You are building the elements in the set by writing the pattern of the set, that is a set builder form. Another is just writing the elements. A set is nothing but a collection of elements in the set. A set, suppose n is nothing but 2, 3, 5, 7 and so on. 2, 3, 5, 7 and so on. 2, 3, 5, 7 and so on is nothing but x such that x is a prime number. X such that x is a prime number. Of course, prime number is a part of a natural number. So, x is nothing but a part of the natural number. I hope it is clear. A set is nothing but a collection of elements. A set. Sets can be represented. Sets can be represented by using Venn diagrams. Venn diagrams are used to represent sets. A Venn diagrams are used to represent sets. How these Venn diagrams are used to represent sets, we will see it. For example, if it is one set, sets are generally represented using Venn diagrams. For Venn diagrams, we used a circle. So, these are nothing but 2, 4, 6, 8, 10, 12, 16 and so on. These are nothing but it is a set of even natural numbers. It is nothing but an set of even natural numbers. This is right. So, if it is 2 sets, now from here onwards our concept will start. Suppose if it is 2 sets, suppose in an ANIL NAIR class of some students, there are some students who like actor A, there are some students who like actor B, there are some students who like both act A and B, both A and B, both A and B. In mathematical terminology, we call it as A intersection B, or in other words, A and B, A and B. The people who like both A and B is represented in sets as A intersection B. Then what is this one? This is nothing but only A. The people who like only actor A. Then what is this? These are nothing but only B. These are nothing but A intersection B. These are nothing but A intersection B. Only A can also be written as A minus B. A minus B is A but not B. A but not B. Or in other words, it is nothing but only A. Only A. These are nothing but only A. I will use some colors. Anything that is which is in red color, which is nothing but only A. These are nothing but only A. Anything which I am putting it in green color, which is nothing but A intersection B. Anything which is in red color, or red we have already used it. Anything which is it in violet color, it is only B. It is only B. A intersection B, only B. Suppose in a class, there might be few students who like only actor A or who like only actor B. There might be students who like both actor A and B. There could also be a students who does not like neither actor A nor B. Neither actor A nor B. This is my entire class where the students like only actor B or only actor B, A or both actor A and B or neither A nor B. This I call it as mu. Mu is nothing but, here it is nothing but my class students. So mu is nothing but the universal set. Mu is nothing but the universal set. Mu is nothing but the universal set. Totally how many regions we got in this set? total number of regions we got in the set. Totally how many regions we got in the set? Let us see. This is one region. This is the second region. This is the third region. Neither A nor B is 4 region. That means if there are 2 sets are there, total I got 2 square. Totally 4 regions I got it. If I got 2 sets, totally 4 regions I got. What are that 4 regions? One is only A, another is only B, another is both A and B, another is neither A nor B. So 2 sets totally. The first important conclusion, if there are 2 sets are there, total how many regions we got? 1, 2, 3. Neither A nor B, it is 4. Suppose if I take 3 sets, each set is represented using a circle. So it is nothing but 1, 2, 3, 4, 5, 6, 7, and outside it is nothing but 8. That means if there are 2 sets, I got 2 square, which is nothing but 4 regions. If there are 3 sets, it is nothing but 2 cube, which is nothing but 8 regions. Extremely important key point. If there are n sets, totally there will be 2 power n regions. If there are n sets, totally there will be 2 power n regions. Please make a note of it, which will be extremely important for us to draw the diagram related to 4 sets. If there are 2 sets, there are 4 regions. If there are 3 sets, there are 8 regions. If there are 4 sets, how many regions you should get? 16 regions you should get. I hope this fundamental understanding it is clear. First we will write, again we will go back to 2 sets and then we will come back to 4 sets and we will use this condition. Suppose if there are 2 sets are there, if a set is represented using a circle, these are the students who like only actor A, actor B, combination is A intersection B. These nothing but only A. These nothing but only B. Outside it is nothing but neither A nor B. Outside it is nothing but neither A nor B. And the totality is nothing but mu. Now this combination of this region is known as N of A union B. Number of students who like at least one actor. At least one actor is nothing but, right? Framework 1. Total students minus N of neither A nor B. That also gives you number of students minus number of students who does not like any actor will give you the number of students who like at least one actor. Or it is nothing but N of only A plus N of only B plus N of A intersection B. That means first it is nothing but only 1, next it is nothing but only 2. Are you all with me? Only at least one is, it could be greater than or equivalent to 1. Greater than or equivalent to 1 means the people who like only one actor or the people who like 2 actors, only 1 or only 2. But fundamental principle of inclusion says N of A union B is also nothing but N of A plus N of B minus N of A intersection B. Minus N of A intersection B. From where you got this? These nothing but A. These nothing but B. What is N of A? Number of students who like actor A. There is a difference between the number of students who like actor A and who like only actor A. If I say that I like chicken, that does not mean that I do not like any other non-veg items. When I say I like only chicken, that means in non-veg I only like non-veg. If I say right, I like only Kareena Kapoor, that means that she is the only heroine whom I like in Bollywood, and which is a fact. N of A plus N of B minus N of A intersection B. From where you got N of A is nothing but N of A is nothing but N of only A plus N of A intersection B. Am I right? N of B is nothing but N of only B plus N of A intersection B. If I add these both, what I will get? N of only A plus N of only B, 2N of A intersection B minus N of A intersection B is this one. So, very, very important. N of A union B is nothing but N of only A plus only B plus N of A intersection B. Or if I remove only, it is nothing but N of A plus N of B minus N of A intersection B. We will solve a lot of set related problems using diagrams. Instead of, we will avoid using this fundamental principle of inclusion and exclusion. First important point, two sets will have 4 regions. What are the 4 regions? We denoted it. What is the second key point? The difference between A and only A. Only A means I will not like anything other than that one. A means I will like something beyond that A also. Two set diagrams. I hope it is clear. Then first important point, we will write it. N of A union B is nothing but N of A plus N of B minus N of A intersection B. Now please put a star mark on an important point. I will come back to that point. N of A union B, there is a positive sign here. N of A intersection B, there is a negative sign here. If the union, it is positive. Intersection, what is the sign that is present? Negative. If the union of two sets is positive, if the union of two sets is a positive sign, I will come back to this after 15 to 20 minutes. Intersection of two sets. If the intersection of two sets, is it in a negative sign? It is in a negative sign. That means if one is maximum, another will become minimum. If one is minimum, another will become maximum. Similarly, if I put A intersection to the left side, N of A intersection B will become N of A plus N of B minus N of A intersection B. That means if minus N of A union B. That means if union has got a negative sign, if union has got a negative sign, intersection will have a positive sign. Intersection will have a positive sign. I hope this concept is clear. Union of two sets, if it is positive sign, intersection of two sets will be negative sign. If the union of two sets has got a negative sign, intersection of two sets is positive sign. Again, I will come back to this point. We will park this concept for some time. I will again bring it back to the execution once I discuss the maxima and minima type number 1. Union positive sign, intersection negative sign. Union negative sign, intersection positive sign. I hope it is clear. Then we will discuss 3 sets. 3 set. A set is represented by using a circle. So it is 3 sets. This is a set which contains everything with respect to A, everything with respect to B, everything with respect to C. These are nothing but total number of students in a class, total number of audience in a theater, any universal set. These are nothing but N of neither A, B nor C. It is nothing but neither A, B nor C. These are nothing but A. These are nothing but B. These are nothing but C. These are nothing but only A. These are nothing but only B. These are nothing but only C. These are nothing but A, B and C. These are nothing but A, B but not C. These are nothing but B, C but not A. These are nothing but AC but not B. Totally how many sets we got? 1, 2, 3. 3 plus 3, 6, 6 plus 1, 7, 7 plus 1, 8. Now, these are nothing but, right, N of A union B union C. Union is nothing but at least one. What do you mean by at least one? It will be either only one, or it will be only two, or it will be only three. Are you all with me? Only one, only two, and only three. Right? Now see here. Only one is nothing but only A plus only B plus only C. Only two means it is nothing but AB or BC or CA. Are you all with me? Only three means since there are three sets, it is A comma B comma C. Intersection of A, B, C, I wrote it as A comma B comma C. This is three sets. This is three sets. But according to the fundamental principle of exclusion, there is also another concept which we will do it, which we will use only when it is required. What is that one? N of A union B union C. It is a N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C plus A intersection B intersection C. These are nothing but the right fundamental theorem of inclusion or exclusion. We will try not to use this formula unless and until it is required. What is the other notation that we discussed? A union B union C is nothing but only one plus only two plus only 3. Relatively, second one is much easy to remember for 4 sets also. A union, B union, C union, D is N of only A, only B, only C, only D. If suppose A union, B union, C union, D is given, what is that one? D is nothing but only A, only B, only C, only D. Next one, only C. 2 out of 4 values. Out of 4 values, I have to take 2 values. So it is AB, next it is AC, next it is AD, and so on up to C comma D. Only 3. Out of 4, select any 3. I hope it is clear. Out of 4, select any 3. I will get ABC, then I will get ACD, and so on up to BCD. Next it will be only A, B, C, D. It's very easy to write down this rule if you understand this. Only 1 plus only 2 or plus only 3. I hope it is clear. A union, B union, C union, D. I hope it is clear. Let me go back to the set. Let me go back. Now see here, 3 sets. 3 sets is nothing but these. What all the things that we got? These nothing but only A. These nothing but only B. These nothing but only C. There are sets are A, B, C. Sets are A, B, C. I am selecting only one. I am selecting only one. Out of 3, selecting any one. 3C1, which is nothing but 3. So 3 regions which I got. Are you all with me? Right? Next one, I am selecting only 2. If I am selecting only 2, out of 3, I am selecting 2. 3C2 is nothing but 3. Again I will get 3 values. What are these 3? AB but not C. BC but not A. AC but not B. Right? I am selecting 3 out of 3. I am selecting 3 out of 3. Out of 3 I am selecting 3. 3C3 which is 1, which is this region. Right? I am selecting 0 out of 3. I am selecting 0 out of 3. 3C0, which is nothing but 1, which is here, neither AB nor C. Neither AB nor C. How many regions are there also? You can easily determine. If 4 sets are there, I want only 2 selections. Answer is 4C2. Then how come we got 2 power 3 as 8? We got 2 power 3 as 8. Why? Because selecting 0 out of 3, it is 3C0. Selecting 1 out of 3, selecting 2 out of 3, selecting 3 out of 3, it is nothing but 2 power 3. Why? Because there is a binomial axiom. What is that axiom? NC0 plus NC1 till NCN. It is nothing but 2 power n. I hope it is clear to you why it is 2 power 3, 8 sets we got. Why we got 16 sets? If out of 4 sets, I am not selecting any, that also I will do it. So it's very easy to, no need for any formulae. It is at least 1 is only 1 plus only 2 plus only 3. At least 4 sets are there, means at least 0. At least 0, 1, 2, 3, 4. It is nothing but total, it will give you the universal set. I hope it is clear. Listen carefully, sir. Maxima and minima, which you will take 20 minutes to solve. If you listen to the class in less than 3 minutes, you can find out the toughest of the question. 2 hours investment of time, 12 marks is guaranteed. Because if you look at the past few years of CAT, Venn diagram, definitely one caselet is coming. Suppose 4 sets are there. 4 sets are there. I am not selecting any. 4C0. 4, selecting 1, selecting 2, selecting 3, selecting 4. 4C0. For NC0, it is 1, it is 4, it is 6, it is 4, it is 1. So how much we got? 16, which is nothing but 2 power 4. So the first important conclusion is, if there are n sets, there will be 2 power n regions. There has to be 2 power n regions. There has to be 2 power n regions. Out of these 16 regions, right, no selection, there will be 1 region. Selecting 1, there will be 4 regions. Selecting 2, there will be 6 regions. Selecting 3, there will be 4 regions. Selecting 4, there will be 1 region. I hope it is clear. Only if you know this, then you will start solving 5 sets, 6 sets also. Otherwise, whatever you know, till 3 sets you will stop it and you will think that this is only set theory. Right? The kind of questions have changed. The kind of complexity of asking a question beyond a formula also has increased tremendously. Now we will do it for 4 sets. Listen carefully, sir. After this one, you will only draw it on your own in your notebook. 4 sets. 4 sets. Now listen carefully. Please do not draw it. Listen to me for 2 minutes, then draw it on your own. Four sets. See here. 4 sets. Each set is 1 circle. This is 1 circle. I'll draw it a little big so that it will be. Please don't draw it first. Listen. This 1 circle. This another circle. This another circle. This another circle. 2 circles horizontally. 2 circles horizontally. Please don't draw it. Listen to me, sir. 2 circles vertically. 2 vertically I have drawn, 2 horizontally I have drawn. Let me see which are, how many regions are there. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Totally we got 22 regions. But if there are 4 sets are there, 2 power 4, which is nothing but 16 regions. 16 regions we have to do it. I hope it is clear. Suppose if I call these set as A, circle as A, this is B, this is C, this is D. Now if you observe closely, please don't draw it. This is nothing but only A. This is also nothing but only A, duplicated. This is nothing but only B. This is also nothing but only B, duplicated. This is A intersection B. Here also A intersection B. That means if I keep a mirror here, this is nothing but the mirror image of these 3. So these 3, either the left side or the either the left side or the right side 3 has to be omitted. Either you can eliminate left side or you can do right side. Similarly, this is nothing but only C. This is nothing but only D. Here also it is nothing but only C. These also nothing but only D. This is nothing but C and D. Here also it is nothing but C and D. So these 3 is duplicated or this 3 is duplicated. If I take this as water, image, bottom it is nothing but the water image. Totally we got 22 regions, out of which 6 regions are written twice. What are that 6 regions which are taken twice? Only A, only B, A intersection B. 3 are duplicated. The left side became the same as the right side. These right side I will eliminate, or the left side I will eliminate, or the top and the bottom are duplicated. Top and bottom are duplicated. Either I will eliminate the bottom or I will eliminate the top. Right? So bottom is nothing but the water image of top 3. Right is nothing but the mirror image of left side. I hope it is clear. 6 regions which needs to be eliminated or can be done. Now what we will do is, we will draw the diagram right again and we will eliminate it. So I think it should be very clear. If you keep this, you remove this. You keep down, you remove the top. If you keep the top, you remove the bottom. So what I will do is, one minute, sir. What I will do is, I will draw the diagram right now for 4 sets. See here, there is 2 here, here it is, and here it is. So total 22 regions. So what I will do is, I will remove these left side, I will remove this bottom. Anything can be removed, right? Left, right, top, bottom. You do anything. Either you remove right or bottom, or you remove left or top, anything. If I remove it, please see here how am I drawing the diagram. First there is a semicircle here. First this is a line. First there is a semicircle. Again there is a semicircle. Here also there is a circle like this. there is a circle like this. Can I say that this is the diagram? If you closely observe, if you closely observe, the diagram became like this. Are you all with me? The diagram became like me. So what I did is, I eliminated this portion, this portion, this portion, this entire portion I eliminated it. I hope it is clear, or you can draw the diagram on your own if you have understood it. I hope it is clear. Left is there, right will not be there. Top is there, bottom should not be there. Top is there, bottom should not be there. Right is there, left should not be there. This is duplicated with this. This is duplicated with this. You can take any, eliminate any two. So the diagram will be, like this. Line, draw a semicircle, draw a semicircle, draw a circle like this, draw a circle like this. Now you do it one by one. This is A, this is B, this is C, this is D. A, B, C, D. This is nothing but only C. Right, left side it is out. This is nothing but only D. This is C and D. This is nothing but only A. This is nothing but only B. A and B. Bottom it is out. Are you all with me? Next one it is present in A. Now here it will be useful. A, B, C, D. Total out of 4. 4C 0. It is one region I should get, which is nothing but outside. Neither A, B, C nor D. This is out. Selecting 1. 4C1. It is 4. 4 only regions. Only A, only B, only C, only D. 4C2, which is nothing but 6. Right, there are 6 regions which has exactly 2 sets. It is present in A, it is present in C. It is present in, these present in A, these present in C, these present in D. This is present in A, these also present in D. This is present in A, these present in B, these present in C. These present in A, present in B, present in C, present in D. These present in A, these present in D, these also present in B. This is present in B, these also present in D. These present in B, these also present in C, present in D. This is present in B and it is also present in C. 4C2, totally 6 regions I need to get. Let us see whether you got 6 regions which contains only 2. A and B 1, C and D 1, A and C 1, A and D 1. Next one, B and C 1, right, B and D 1. So what are that we got? AB we got, AC we got, AD we got, BC we got, BD we got and CD we got, which is 6. I hope it is clear. 4C3, which is nothing but 4. 3 sets I should get 4. Let us see whether there are 4. Easily when you are drawing the diagram only you will understand. This is 1, this is 2, this is 3, this is 4. That also we got. 4C4 is nothing but 1. There is one region which contains all 4. I hope 4 sets diagram is clear to everyone. Kindly reply in the live chat whether 4 set diagram is clear to you. Kindly reply if it is clear to you. Is the idea clear how to draw these 4 set diagram? Write 4 set diagram. 4 set diagram. Even if you do not draw the diagram, just by visualization, if I say, if 5 set diagrams are there, neither A, B, C, D nor E one value I will get. 5C1, 5 values I will get, which contains only A, only B, only C, only D, only E. 5C2, 2 values I will get 10. The diagram is for our understanding. A diagrammatic representation is for our understanding. But once you understand it, you can solve a lot of these problems orally. Everybody kindly reply in the live chat if you can draw 4 sets on your own. Kindly reply, sir. I want each and every viewer to reply it in the live chat if it is clear to you. These things are not taught in our school days. This kind of teaching is not taught. What is taught? How to use fundamental principle of addition is taught, multiplication is taught. But in permutation and combination, in our school, fundamental theorem of subtraction will not be taught. If you do not teach that one, then probably Bayes' theorem you will not be able to understand it. If Bayes' theorem, if you don't understand it, conditional probability, how will you understand it? Everything is a connecting of the dots. If you understand this, this will be more effective. If this is effective, this which will be much more effective. I hope everybody it is clear. 4 sets, I hope it is clear. Kindly, after watching this video, right, please pause it and draw the diagram on your own and list the regions on your own. These in CAT caselet, one huge RC passage will be given. All you have to do is just take that values and plug in. Answers will come out. And people do not know how to draw the diagram, and they say that the paper is tough. Paper is tough because your understanding of the concept is extremely on the poorer side. Your selection of questions is on the poorer side. I hope everybody it is clear. Right, this is how I teach. Maybe that could be the reason lot of sincere and serious CAT students who want to get into IIMs are enrolling for my batch, which is starting from June 1st. In case if you are interested, you can WhatsApp me to know more, right? That is at the beginning of the class also. I have told you clearly, the best thing is all the classes are taken by me. How many hours? You cannot even imagine. Totally 480 hours of content I am going to give, which is a combination of live and a pre-recorded content. 2 sets, 3 sets, 4 sets. Introduction, it is over. Now, we will just plug in the values and we will solve the problems. Now, this is nothing but writing down the elements, writing down in a set builder form. The objects in a set are called the elements of this set. I hope it is clear. So the physical pictorial representation of sets is generally done by using Venn diagram. It is generally done by using Venn diagram. Some sets introduction we did it. All that intersection A minus B, everything A minus B are nothing but the elements which are only in A. B minus A represents the elements which are only in B. I hope it is clear. Some foundation problems, then we will get into an maxima and minima problem. Some foundation problems. Now, read the question. Foundation, most of you can do it. I know that you are all waiting for a maxima minima problems. 15 to 20 minutes, some application of the concepts we will do it. Then we will get into an ANIL NAIR's way of solving maxima and minima by taking original CAT questions. In a class of 70 students, mu is nothing but the 70 students, right? 40 students like a certain magazine, right? 40 students like certain magazine, let me call it as magazine A. 37 students like another magazine. Find the number of students who like both the magazines simultaneously if every student likes at least one magazine. Likes magazines. If this statement is given, then neither A nor B will become 0. If I call it as A, this will become 40 minus A. This will become 37 minus A. So total mu is nothing but n of A union B plus n of neither A nor B. N of neither A nor B. N of A union B plus N of neither A nor B. So it is nothing but 70 equivalent to N of A union B is nothing but only 1 plus only 2 plus N of neither A nor B. If the statement is given, it is 0. 70 equivalent to 40 minus A plus 37 minus A plus A. Minus A plus A cancel. So these is nothing but 77 minus A. A is nothing but 7. A is nothing but 7. That means number of students who like both the magazines, it is nothing but 7. Number of students who like only A is given by A minus B here, which is nothing but 33. Number of students who like only B is nothing but 7. 37 minus 7 is 30. Number of students who like at least one magazine is nothing but, right? So 70 minus 0, which is nothing but 70. Which is nothing but 70. No usage of this you should know, sir, because it will be extremely useful for solving few problems. Mu equivalent to N of A union B plus N of neither A nor B. For me, this solution is not important. Why I star marked these important key point? That also we will see. Mu equivalent to N of A union B plus N of neither A nor B. Now, please write down, note, what is that important key point which we wrote? Mu is nothing but N of A union B plus N of neither A nor B. Neither A nor B. If mu value is given, some constant value is given, number of students in a class, number of people watching a movie, number of people in a park, number of lecturers in a college, if it is given, so N of neither A nor B, N of neither A nor B will become mu minus N of A union B. Mu minus N of A union B. That means if this is minimum, because there is a minus sign, this will be maximum. This will be maximum because it is related with a minus sign. If this is maximum, this will be minimum. Please write this point. I will get back to this point under maxima and minima. Neither A nor B. If it is minimum, what should be the value? N of A union B. N of A union B should be maximum. Should be maximum. Are you all with me? If N of A union B is maximum, N of A intersection B should be minimum. Why? Because union and intersection are also related with minus sign, which we discussed. Neither A nor B. Please write down this point. If neither A nor B, if I have to find out minimum value, union value should be maximum because it is with minus sign. If union is maximum, intersection will be minimum. Why? Because N of A union B is N of A plus N of B minus N of A intersection B. I hope the idea is clear. Another important key point, please write down. N of neither A nor B. N of neither A nor B. It is nothing but mu minus of N of A union B. If mu is constant, mu is nothing but the universal set, some value is given, mu is N of A union B is N of A plus N of B minus N of A intersection B. This is nothing but mu minus of N of A plus N of B. Minus into minus is plus, which is N of A intersection B. Now, very, very important conclusions. Otherwise, minimum and maximum problems, you will leave it. Now, see here. So neither A nor B, if it is maximum, union it will be minimum. If this is maximum, plus sign, intersection also it will be maximum. Please write down this point which we wrote it 1 minute before. Neither A nor B, if it is maximum, A intersection B will be maximum, A union B will be minimum. A union B will be minimum. If this is minimum, A intersection B will be minimum and A union B will be maximum. A union B will be maximum. I hope the idea it is clear. I hope the idea is crystal clear to you. Just write down this key point. I will tell you its application when I am discussing maxima and minima. Next one. In a group of 64 persons, there are people who like tea and there are people who like coffee. Total 64. Right? Every person likes either tea or coffee. It should be given, otherwise neither A nor B, it will be 0. There are people who like tea. Okay, tea but not coffee. Okay, I will come back to it. This is not 26. Right? There are people 34 drink tea. 34 drink tea. There are remaining people who drink coffee, out of which 26 drink tea but not coffee, which is A minus B. These are nothing but 8. 26 plus 8, 34. These are nothing but 30 over. How many drink tea and coffee both? N of T intersection C, which is nothing but 8. How many drink coffee but not tea? That means coffee but not tea. Or how many drink only coffee, which is nothing but 30. Very easy question. Just drawing the diagram, you will get these answer. Question number 2. I hope it is clear. Question number 3. In a class of 60 students, people opted mathematics and mathematics but not biology. It is a two-set diagram. It is a two-set diagram. So there are people who like mathematics and there are people who like biology, only maths, only biology, maths not biology, all that it is given. So these 30. 16 have opted for mathematics, it is 16. 12 have opted for mathematics but not biology. So remaining will be 4. Find the number of students. Every student opts for either maths or biology. It is something which needs to be stated. 16. These are nothing but 14. How many number of students opted for biology but not mathematics? N of B minus M. So answer is nothing but 14. B minus M. Answer is nothing but 14. Easy questions which we will solve. In a class of 70 students, there are 70 students are there. 40 like certain magazine. Okay. 37 likes certain another magazine. How many? 7 like neither. 7 like neither. How many students like at least one? At least one is nothing but mu minus neither A nor B. Mu minus neither A nor B. So 70 minus 7, which is nothing but 63. You don't need to do it. Suppose if you do it, find the number of students who like both the magazines simultaneously. So if this is X, these are nothing but 40 minus X. These are nothing but 37 minus X. 40 minus X plus 37 minus X plus 7 is nothing but 70. These are nothing but 84 minus X is nothing but minus X plus X cancel. It is nothing but 70. X is nothing but 14. x is nothing but 14. I hope the idea it is clear. First and second question, I hope it is clear. Next one. In a school, 45% of the students play cricket. Some play hockey, some play both. Again, it is a two-set diagram. Two-set diagram. We will do few three-set diagrams. Then we will go into maxima and minima. So there are people who play cricket. There are people who play hockey. This is cricket. This is hockey. This is nothing but cricket and hockey. Right? So nothing is specified about it. Neither cricket nor hockey. This we need to determine. So it is percentage. So it is 100. How many play cricket? 45 play cricket. How many play hockey? 30 play hockey. Right, out of 100. 15 play both. If it is 15, so it is only C will be 30. 15, this will be 15. 30 plus 30, 60, this will be 40. How many percentage of the people will play neither cricket nor hockey, which is nothing but 40%. I hope the application is very, very easy. You don't need to draw a diagrams. These are all foundation questions. Then slowly I will get into, right? There are maxima and minima. There are 1,000 students. There are people who are drinking tea. There are people who are drinking coffee. There are people who do not drink either tea or coffee. There are people who like tea. There are people who like coffee. These tea, these coffee. Total there are 1,000 students are there. 30 students do not drink neither tea nor coffee. 30 is outside. So these 6. X, it is nothing but 650. So this will become 650 minus X. Cricket is coffee, it is nothing but all the time my mind is on cricket. These 390 minus X. So it is nothing but 650 minus X plus 390 minus X plus X. Only 1 plus only 2. It is nothing but N of A union B, which is nothing but 940 minus X equivalent to 970. 940 minus X, I hope it is not 940, it is 1040. So answer is nothing but 1040 minus 970. It is nothing but X. X is nothing but 70. X is nothing but 70. I hope the idea it is clear. How many drink both tea and coffee? Answer is nothing but 70. We will do 3 set diagrams. Till now we did 2 set diagrams. This question is based on a 3 set diagram. 3 set diagram. There are number of students. Mu value is no. There are people who play football. There are people who play hockey. There are people who play cricket. There are 3 are there. There are people who play football. There are people who play hockey. There are people who play cricket. There are people who play cricket. Just draw the diagrams, you will get the answer. There are people who play cricket. 8 play all the 3 games. So 8. This mu value is nothing but 150. This value we need to determine. Question mark. 65 play football. Okay. 50 play hockey. Okay. 75 play cricket. These also okay. 35 play hockey and cricket. 35 play hockey and cricket. 8 is already over. So 27. 20 play football and cricket. 8 is over. So it is 12. 42 play football and hockey, which is nothing but 34. Which is nothing but 34. I hope it is clear. So football and hockey. Football and hockey is this combined set. Football and hockey it is 42. Only 8 I got. So remaining it is 34. Hockey and cricket is nothing but 35, 8 and 27. Football and cricket is nothing but 20. So football it is 65, 34, 42, 54, which is nothing but 11. 34 football, 50 play hockey. Why we got hockey and cricket, how much it is? 35. 35 means this set is 12 plus 20 is 34 plus 8, 42. 42 plus 21 is 68, which is minus 18. 12 plus 27 is 39. 47, which is nothing but 28. 40, 48, 75. I hope it is clear. So we got minus 18 here. We got minus 18. Let us check again why we got minus 18. Hockey is 50. 8 is playing. Hockey and cricket is nothing but 35. 8 is nothing but 27. Football and hockey it is nothing but football and hockey it is 42. So what is this value? 11 minus 18 plus 28, right? Theoretically it could be true, but it is coming out to be negative. People only play hockey cannot be negative. Just we will proceed. 34 plus 12 plus 27 plus 8 plus question mark equivalent to 150. 11 plus 28 is 39. 39, right? So 39, 28 minus 7 is nothing but 21. 34 plus 8, 42. 54. 54 plus 27, which is nothing but 81. Plus question mark equivalent to 150. Question mark is nothing but 49, right? Even though the answer is 49, number of students who are playing hockey minus 18 seems mathematically incorrect, but we will go with the answer option. We cannot say is also seems to be option because there is negative value. Assume that it is cannot say is not there, so tick the marker. This is mathematically incorrect. I hope it is clear. Next one. Now come set theory, maxima and minima. We cannot get a negative value. Mathematically there is a fallacy. There is a mathematical fallacy here. The question, there is an inconsistent data that is given. The values are not right properly kept to satisfy the there is a mathematical fallacy. In fact, in simple language, it is data inconsistent. The data is inconsistent. How can the number of people who play cricket will be negative, right? It cannot be negative, right? Next one. Set theory, maxima and minima. I want each and every student to listen to it with utmost attention. Extremely important types. Extremely important type which we are going to discuss. Now see. Set theory, maxima and minima. There are two types of questions that will come in your examination. Type 1, mu will be given, n of A will be given, n of B will be given, n of C will be given. All the values will be given in your question. N of neither AB nor C, value will be given it as 0. So we have to determine n of A intersection B intersection C minimum value, and we have to determine A intersection B intersection C maximum value we have to determine. Very, very, very important topic for especially management examination aspirants. Type 1. Type 1, first I will discuss the traditional method, then I will tell you ANIL NAIR classes approach or ANIL NAIR's method, traditional method. Mu n of A, n of B, n of C is given. Neither AB nor C is 0. A intersection B intersection C. Minimum we have to determine. A intersection B intersection C. Maximum we have to determine. First we will discuss the concept. Concept for type 1. Type 1. Mu is given, n of A is given, n of B is given, n of C is given. All these are given. N of neither AB nor C, it is given as 0. So, first see here, sir. Mu is nothing but n of A union B union C plus n of neither AB nor C. N of neither AB nor C. Neither AB nor C, it is 0. So, mu is nothing but n of A union B union C, which is according to fundamental theorem of inclusion and exclusion, n of A plus n of B plus n of C minus of n of A intersection B, B intersection C, A intersection C plus n of A intersection B intersection C. This is something which is required for us to solve the problem. Why? Because n of neither AB nor C is 0. Mu is equivalent to n of A union B union C. N of A plus n of B plus n of C. A intersection B, B intersection C, A intersection C, and A intersection B intersection C. We will draw in terms of diagrams. This. This is mu, this is 0. Let me call these values as A, B and C. This is A, this is B, this is C. Mu is some constant K. N of A, mu value is given, n of A value is given, n of B value is given, n of C value is given. All these values are given. Some constants are given. I am giving constants to K, K1, K2, K3. This is K1, next is K2, next is K3, minus n of A intersection B, A plus X, minus n of B intersection C, C plus X, minus A intersection C, B plus X, plus A intersection B intersection C, which is X. Sum of three constants is also another constant, K4, minus of A plus B plus C, minus X minus X minus X, minus 3X plus X, minus 2X. 2X is nothing but K4 minus K minus of A plus B plus C. Constant, constant, constant. 2 is constant. That means if X is minimum, A plus B plus C should be maximum. X is minimum, this region should be maximum. If X is maximum, A plus B plus C should be minimum. A plus B plus C should be minimum. I hope it is clear, right? For it to be become, for this to be minimum, these three regions should be maximum. For it to be maximum, these three regions should be minimum. Please draw this beautiful conclusion. If X is minimum, A plus B plus C is maximum. If X is maximum, A plus B plus C is minimum. This is a traditional method. This is what you will find it out in your regular textbooks. I will teach you ANIL NAIR's method after you understand the traditional method. Please write down this point. So in type 1, what is the concept? Type 1 concept is if x is minimum, a plus b plus c should be maximum. A plus b plus c should be maximum. If x is maximum, a plus b plus c should be minimum. A plus b plus c should be minimum. Example, mu is 100, n of a is 90, n of b is 80, n of c is 70. N of neither AB nor C, it is 0. N of A intersection B intersection C, minimum I need. N of A intersection B intersection C, maximum I need. Maximum I need. Listen carefully, sir. Listen carefully. For this question, solution. Listen carefully. First, we will do minimum. X minimum means a plus b plus c should be maximum. It is the 3 sets. This one, and this one. Total, it is nothing but total. Praveen, okay, no issues. If this is 100, this is 90, this is 80, and it is 70. Listen carefully, sir. Listen carefully. I am doing a minimum. Minimum means if this is x, which all regions should be maximum? Anyway, it is given as 0. This should be maximum. This should be maximum. This should be maximum. Am I right? For it to be maximum, now see here. This has to be maximum. For it to be maximum, this entire value, what it is? 90. What is this value? 100. That means this value plus this value, these 3 combination, I should get remaining 10. Do you agree with me? This entire circle is 90. Outside it is 100. Remaining 3 should give me 10. Are you all with me? But I want that middle value to be maximum. So I will give 10 here. I will keep 0 and 0. Are you all with me? If this entire circle is 70, outside it is 0. This plus this should give me 30. This should be maximum. So give entire 30 there. Are you all with me? And this is total 80. If this is total 80, outside it is 0. This plus this should give me remaining 20. But this is maximum. So give entire 22 there. So answer is 30 plus 20 plus 10 plus x equivalent to 100. So x minimum is nothing but 40. X minimum is nothing but 40. Again I am explaining. Please listen carefully, sir. If you understand, anyway, these, right, this is an easy question, but if you understand Anil Nair's way of solving, you can solve it in less than 10 seconds. N of A is 90, N of B is 70, 80, N of C is 70. Second time I am explaining, listen carefully. N of neither AB nor C. Neither AB nor C, it is 0. Second time I am explaining. This circle is nothing but 90. This circle is nothing but 80. This circle is nothing but 70. This is nothing but x. X minimum means A plus B plus C should be maximum. A plus B plus C should be maximum. A plus B plus C is, this is A, this is B, this is C. This should be maximum. These outside 0. So total it is given it as 100. That means if this entire circle value is 90, this value plus A value plus this value should give me remaining 10 because it is 0. I want maximum. Give the entire 10 to A, remaining 2 keep it as 0. If this entire circle value is 70, this value plus B plus 0, anyway it is 0, it should give you 30. Because B is maximum, give it to 30. Are you all with me? If this entire circle value is 80, remaining 3 it should be 20. So give C value 20. Are you all with me? So answer is 30 plus 20 plus 10 plus X, remaining all are 100. So X value is nothing but 40. I hope you have understood how to determine intersection A intersection B intersection C minimum value, which is nothing but 40, by using traditional method. Then I will discuss optimal method. A intersection B intersection C minimum, I hope it is clear. I hope the idea is perfectly clear. Then we will do maximum. Kindly reply in the live chat if it is clear for you. Mu is 100. N of A is 90. N of B is 80. N of C is 70. Now we require A intersection B intersection C maximum. Maximum we require N of neither AB nor C is 0. Neither AB nor C is nothing but 0. Now see here, what is the concept that we discussed? X maximum. X maximum is nothing but A plus B plus C minimum. X maximum is nothing but A plus B plus C minimum. If it is A plus B plus C minimum, so this is nothing but A. This is nothing but B. This is nothing but C. This total, it is nothing but 100. This is nothing but 0. This is X. A plus B plus C minimum means A should be minimum, B should be minimum, and C should be minimum. So this will be 0, 0, 0. If this is 90, this will be 90 minus X. This is 80, this will be 80 minus X. If this is 70, which is 70 minus X. So the answer will be 90 minus X, 80 minus X, 70 minus X. 90 minus X plus 80 minus X plus 70 minus X plus X equivalent to 100. 170, 240. 240 minus 2X. It is nothing but 100. X is nothing but 70. 70. Traditional method, time consuming method. You know that I generally avoid using X and Y's. My entire research is spending finding out the optimal ways. This is a traditional method. Everybody kindly reply in the live chat if a traditional method is clear to you. If it is 4 sets, 5 sets, you cannot use this traditional method and get the answer in seconds. But if you understand Anil Nair's way of solving the question, it can be solved within seconds. If you understand that root cause of the problem for which I am known for me, there is a logic behind every concept. When I sit and solve a problem, right, I ask myself, how can my students solve these questions faster than they ever thought possible? Everybody kindly reply to in the live chat if method 1 is clear to you. Then I will get into Anil Nair's way of solving method number 2. Everybody kindly reply, sir. Kindly reply. It is clear? Now, Anil Nair's way of solving. Right? Easiest, fastest, best approach to solve this question. Easiest, fastest, best approach to solve this question using common sense. Using common sense approach. Using common sense approach. Now, see the concept. See the concept. Observe these two circles which are far. If it is far, can I say that A intersection B, it is 0. A union B, it is maximum. Observe these circles coming and colliding. Intersection value, it is increasing. If intersection value is increasing, union value, it is decreasing. Observe again two circles coming together. Intersection value is further increasing. Union value is further decreasing. Am I right? That means union and intersection values are inversely related to each other. Inversely related to each other. That means simple concept. Please write down this approach. Please write down after understanding this. Just if you observe the behavior of the circles far from coming close, if the intersection is maximum, that is what I said. I will come back to you at the beginning of the class this point. Union is nothing but minimum, right? If the intersection is minimum, union is nothing but maximum. Union is nothing but maximum. I hope it is clear. Intersection maximum we require, make union minimum. Intersection minimum we require. If I want to find out the intersection minimum, union will be maximum. If the union is maximum, when the union will be maximum? When the sets are disjoint sets. Are you all with me? Intersection will be maximum when the intersection will be minimum. Intersection will be minimum. Intersection is minimum when the union is maximum. When the union will be maximum? When the sets are completely disjoint to each other. That means this will give an understanding of the question that for to make intersection minimum, union should be maximum. That means make the sets disjoint. Please write down. For the intersection to be minimum, if whenever I want the intersection to be minimum, union should be maximum. Union maximum means the sets should be disjoint sets. Whenever he is asking for intersection minimum, make the sets disjoint, or in other words, separate the set values. you will easily get the answer. You will easily get the answer. Now let us take some simple example, then we will solve the question. Example 1 which we took it. Mu is 100. N of A is 90. N of B is 80. N of C is 70. N of neither AB nor C, neither AB nor C, which is nothing but 0. N of A intersection B intersection C, minimum. N of A intersection B intersection C, maximum. Case 2. N of A intersection B intersection C, maximum. Right? Think logically. Intersection is maximum. When the intersection is maximum, union should be minimum. When the union will be minimum, when the sets collide or set is a part of another set. Set is a part of another set. Can I say that? Suppose N of C is 70. N of C is 70. In these 80 people who like subject B, if I make 70 people who like subject C, automatically I will get maximum. In the 90 people, if I make 70 people also like subject C, which is nothing but maximum I will get, answer is nothing but the 70, which is the lowest of the three values, which is the lowest of the three values, lowest of the three values. Everybody listen to me. Suppose I got three kinds of ice creams. One is vanilla, another is strawberry, another is chocolate, another is chocolate. Think logically. There are 10 students in the class. There are 10 students in the class. How many students got maximum? Right? There are 8 vanilla chocolates. There are 7 vanilla chocolates. There are 5 chocolates or ice creams, whatever it is. 8, 7, 5, there are 10 students. So I called student 1, gave him vanilla, student 2, vanilla, student 3, vanilla, student 8, vanilla. Student number 1 to 8 got vanilla. I want how many maximum number of students who get all the 3 chocolates. In that 8 students who got vanilla chocolate, I called 7 more students and I gave them strawberry. That means in that 8 students who got vanilla ice cream, 7 also got strawberry. That means how many students got vanilla and strawberry, which is nothing but 7. In that 7 students who got strawberry, I called 5 students and I gave them chocolate also. So how many students got chocolate, vanilla and strawberry? Obviously 5. So out of 100 students, 90 students like actor A. In that 90, 80 also likes actor B. A 70 also likes actor B. So you think mathematically also, intersection is maximum. If the intersection is maximum, union will be minimum. Disjoint means union is maximum. Coming together, the value will decrease. One is part of other. One set is a part of other. The value will further decrease. 70 is a part of 80. 70 is a part of 90. So answer for this question is 70. You don't need any mathematics for this. A simple common sense, easiest, fastest, best approach is take the lowest of the 3 values if neither A, B nor C is given as 0. I hope it is clear. Now intersection minimum also we will do it. These are all, the mathematics is nothing but common sense, sir. mu is 100, n of A is 90, n of B is 80, n of C is 70, n of A intersection B intersection C minimum. Listen carefully. Listen very, very carefully, sir. Right? Intersection is minimum. Intersection is minimum. That means union should be maximum. Union should be maximum. Union is maximum when the sets are disjoint sets. When the sets are disjoint, separate both of them. 90, 80, if I separate, how much it is? This is 90 and it is 80. 90, 80 if I separate, how much it is? 170. But there are 100 students. Inside value is always less than or equivalent to outside. Are you all with me? Right? So, inside it is 170, outside it is 100. How much maximum it can be? Maximum. Union means intersection is minimum means union is maximum. Make it separate. 170. 170 is greater than 100. That means 70 should be the value that should be combined. If 70 is combined, this is 20, this is 10 and it is 0. Are you all with me? 70 will be the value. So maximum intersection, right? I got it is nothing but 70. Do 70 with the third one. 70 with 70. Separate it. 70 with 70, if I separate it, how much it will be? 140. Outside, how much it is the value? 100. Inside value has to be less than or equivalent to outside. 140 is how much more than 100? 40. So what is the answer for the question? 40. Are you all with me? Sir, can I take A and C and then do it with B recursively? Definitely. First of all, I want intersection minimum. Intersection minimum means union should be maximum. Union maximum means sets are disjoint. Make the sets disjoint. 90, 70. If I separate it, it is 160. Outside it is 100. Inside cannot be greater than outside. So common it will be 60. Do it with the third value. 60 with 80. Separate it is 140. Outside it is 100. 140. 100. How much it is more? 40. Are you all with me? I hope it is crystal clear to you. It is an extremely easy question if you understand it. Two more examples, then we will solve. CAT questions, toughest CAT questions, very, very easily. Let me take the exact questions. Mu is nothing but 100. N of A is nothing but 90. N of B is nothing but 80. N of C is nothing but 75. N of D is nothing but 70. N of neither A, B, C nor D, it is 0. It is 0. No mathematics required, sir. First question, N of A intersection B minimum. A intersection B minimum. Intersection minimum. That means union is maximum. Union is maximum. That means sets should be disjoint. Make the values separate. 90, 80. If I separate 170. 170 is how much more than 100? 70. First one answer is 70. Second one, N of B intersection C minimum. B intersection C minimum. Intersection minimum, separate it. 80, 75, 155. Outside it is 100. So what will be the value? 55. Third one, N of A intersection C minimum. A intersection C, 90, 75. Separate it, 165. How much more than 100? 65. Fourth one, N of A intersection D minimum. A intersection D minimum. 90, 70, 160, more than 100, 60. If it is less than, then the value is 0. That will be my next question. All the questions can be solved orally. N of A intersection B intersection C minimum. A, B, C we require. A and B, 170, 70 we got. Do it with the third one. 70 with 75, 145. Outside it is 100. Answer is 45. Where am I using mathematics? Single step. I have seen some books, some CAT papers where they are solving a full page and the teachers are telling please skip this question. What skipping the question which can be solved it in seconds? Next one, N of A intersection B intersection D. A, B, D. A, B, I got 70. 70, 70, 140. 140, 100, it is 40. 7 problems. A intersection, B intersection, C intersection, D minimum. Minimum is nothing but for this I got 70. For this I got 145 means 45. 70, 45, 115, which is nothing but 15. Are you all with me? I hope you enjoyed this magical way of solving the question. Without even putting pen on the paper, you can solve this question very easily. Very easily. Intersection is minimum. That means union should be maximum. Union is maximum. Make the values away from each other. But inside value cannot be greater than outside value. Check how much it is greater. That will be the answer. 90, 80, separate 170. Greater than 100, minimum will be 70. AC, separate it. Why we are separating it? Why? Because the set intersection minimum means union is disjoint. AC, 90, 75, 165, 65. Please look into it. I hope everybody can solve these questions absolutely. Without even using pen on the paper, you can solve these questions orally. I hope the idea it is clear to you. Next, one more question which we will solve, which is a CAT replica question. Let us take some CAT replica questions. Mu is nothing but 150. Two more questions which I will solve. Mu is nothing but 150. Sorry. N of A, it is nothing but 100. N of B, it is nothing but 30. N of C, it is nothing but 75. N of D, it is nothing but 80. 80. One by one we will solve. N of neither A, B, C nor D. Neither A, B, C nor D. It should be 0 according to type 1. First one. N of A intersection B minimum. Intersection minimum. Union is maximum. 130. Separation is 130. 130 is less than 150. So minimum value is 0. Second one. N of B intersection C minimum. Intersection minimum. Union maximum. 30, 75. Separation is 105. Less than 150. It is 0. N of C intersection D, which is minimum which I want. 75, 80. Separation is 155. How much it is more than? 5 more than. Next it is N of A intersection B intersection C intersection D. Minimum value. A intersection B intersection C intersection D. This is nothing but 130 less than 150. 0. This is nothing but 80 plus 75 155, which is 5. 0 plus 5. 5 is less than 150. Answer is 0. Kindly reply in the live chat whether this CAT replica question is clear to you. CAT replica question, I hope it is clear to you. Any doubt in this question? I hope it is clear. 130 separation is 130. 130 is less than 150 is 0. CD 155. It is 5 more than 150. It is 5. 0 and 5. 0 plus 5. It is nothing but 5. 5 is less than 150. Idea clear? Next one. Third question. Third one. Once you understand, these all are very, very easy questions. These mu is nothing but 100. N of A is nothing but, original question I am taking 80%. N of B is nothing but 90%. N of C is nothing but 75%. N of D is nothing but 70%. N of neither ABC nor D, it is given as 10. Anyway, it is given as percent. All these values can be eliminated. 90, 75. What will be the value of N of A intersection B intersection C intersection D? It is minimum value we want. What we did previously, because it is 0, we took the base value as mu value. 80 plus 90, 170. 100, 10 is there. So 170 is compared with 90, because 100, 10 should be subtracted before it is 0. 70 minus 90, which is 80. 70 and 75. Intersection minimum means union maximum. Separation will give you 145, because it is neither ABC nor D is 10. So 145 minus 90 is nothing but 55. 80 with 55, 135. Base is nothing but 90. Answer is nothing but 45. A 5 minutes question can be translated into less than 45 seconds if you know Anil Nair's way of solving the question. 80, 90, 170, 170. Why I took the base value as 90? I hope it is clear, because previous question neither ABC nor D, it is 0, so I took it as 100. Now it is 10. 100 minus 10 is 90. I hope the idea it is clear. Very easy question if you know it. Hi all, welcome to Anil Nair Classes YouTube channel. In the previous class, we were discussing about set theory, maxima and minima. Praveen, pennu jodu. Set theory, maxima and minima. We discussed type 1. So another 45 minutes of class is left to discuss about type 2. Right now we will discuss type 2. Before I start the class, kindly acknowledge in the live chat whether is audio everything clear. Are you facing any streaming issues? This will be a very short class. Type 2 concept and the foundation problems, explaining you how you should solve the problems. In type 1, what we did, I'll just, in type 1, what we discussed in type 1, we discussed when the mu value is given, n of A value is given, n of B value is given, n of C value is given, n of neither A, B nor C is 0. How to find out n of A intersection B intersection C minimum and maximum? Type 1 we discussed, type 2 we will discuss right now. Type 2. In the type 2, mu value will be given, n of A value will be given, n of B value will be given, n of C value will be given, n of A intersection B value will be given, n of B intersection C will be given, n of A intersection C value will be given. All these values will be given. All these values will be given. We have to find out n of A intersection B intersection C minimum value, and we have to find out n of A intersection B intersection C maximum value. What is the difference between type 1 and type 2. Type 1, these values are only given. Mu is given, n of A, n of B, n of C. Neither A, B nor C is 0, but all these values are given. Mu given, n of A given, n of B given, n of C given. A intersection B, B intersection C, A intersection C. We have to find out A intersection B intersection C, minimum value and the maximum value. Type 2. First we will discuss the concept. Then we will execute the concept. Type 2. We will write down here, mu will be given, n of A will be given, n of B will be given, n of C will be given, n of A intersection B is given, B intersection C is given, A intersection C is given, n of A intersection B intersection C, minimum value I need to determine, and n of A intersection B intersection C, maximum value we have to determine. Suppose I am taking a class for 60 students. One student is making noise. I will ask one student to leave the class. There is another student who is making the noise. I will ask him to leave the class. I will keep on asking the students who are creating disturbance to the class to leave the class until there is minimum one student present in the class. I cannot take class for the walls. So, I have to keep on decreasing value, such a value that the region value will be greater than or equivalent to 0. We will get a linear expression, x minus 10 greater than or equivalent to 0. From there we will get the value of x. I hope it is clear. Suppose if 3 sets are there, A, B and C. It is comparatively easy when compared to type number 1. A, B and C. I am determining A intersection B intersection C minimum. Minimum means I have to keep on decreasing because all these are students and it is an integral value. The value will keep decreasing by 1, 1, 1. So if this, why am I keeping minus 1? Because I want minimum values. Minimum value is how much the value can keep on decreasing till you reach a tipping point. A intersection B value is given which is constant. If it is minus 1, this will be plus 1 because minus 1 plus 1 is 0 which is constant. D is also plus 1 which is 0 because A intersection C is given. If it is plus 2, this will be minus 2, another minus 1 will come because n of A is given. If it is minus 1, this will be plus 1. Total n of B value is given. So if it is minus 1, this will also be minus 1. So if it is plus 2, this will be minus 2. I hope it is clear. So total mu value is also given. There are 4 negatives are there. There are 3 positives are there. So it will be plus 1. Why? Because minus 1, minus 1, minus 1, minus 1, minus 4 plus 4, it is 0. That means if this portion is minus 1, what are the other values which I am getting? Minus 1, minus 1, minus 1, minus 1. What is this portion? Only A. What is this portion? Only B. What is this portion? Only C. That means whenever you are determining the minimum and maximum for this value, if it is minimum, only regions should be greater than or equivalent to 0. Only regions should be greater than or equivalent to 0. If I want maximum, other than only regions, it should be greater than or equivalent to 0. Other than only regions, it should be greater than or equivalent to 0. I hope the idea is clear. From where we got these only regions greater than or equivalent to 0? Why? Because if this is minus 1, A intersection B is constant, so it should be plus 1. Minus 1 plus 1, minus 1 plus 1. There are 2 negatives, so there will be 2 positives. So, in this kind of type 2 problems, to determine minimum, only regions should be greater than or equivalent to 0. To determine maximum, other than only regions will be greater than or equivalent to 0. I will do the first problem. Two more problems, we will do it together. Then I will tell you, write Anil Nair's way of solving where you can optimize the number of steps. Question. First question. Let me tell you the values. Mu is nothing but 200. N of A is nothing but 120. N of B is nothing but 90. N of C is nothing but 75. N of A intersection B is nothing but 50. N of B intersection C is nothing but 40. N of A intersection C is nothing but 25. So we need to find out A intersection B intersection C minimum value and N of A intersection B intersection C maximum value. Maximum value we have to determine. Listen carefully, sir. We will do step by step. Solution. It is a 3 set. A, B and C. So this will be like this. Mu is 200. N of A is 120. B is 90. C is 75. 120, 90 and 75. See here, how am I doing? A intersection B intersection C, I will call it as X. Minimum value we require. This is nothing but A. This is nothing but B. This is nothing but C. Traditional method. A intersection B is 50. So this will be 50 minus X. A intersection C will be 25. Already X is present. So it is 25 minus X. A is 120, which is constant. There are 2 minus X. So there will be one more plus X. 50 plus 25 is 75. So this will be 45 plus X. I hope it is clear. N of B intersection C is 40. So it is 40 minus X. N of B is 90. So 50 plus 40, it is nothing but 90. So it will be 0. There are 2 negatives X. So there will be 2 positives. 0 plus X is X. C is 75. 25 plus 40 is 65. So it will be 10. There are 2 minus X. So there will be 2 10 plus X. Outside I need to do it. Neither A, B nor C, nothing is given. This entire value is nothing but 120. These 120 plus 40, 160. 160 plus 10, which is nothing but 170. Out of 200, 170 is there. 30 it is there. There are 2 plus X. So there will be 30 minus X. I hope it is clear. Again I am explaining. This value, listen carefully, sir. Once you understand, you will do it very fast. This is X. A intersection B is 50. So this will be 50 minus X. B intersection C is 40. This is 40 minus X. A intersection C is 25. So this is 25 minus X. Next one. N of A is 120, 50 plus 25 is 75, remaining will be 45. There are 2 negatives X, there will be 2 positives X. If there is 90, 50 plus 40, 90, nothing is left 0. There is 2 minus X, so there will be 2 plus X. 25 plus 40, 65, remaining is 10. To determine the minimum value, only regions should be greater than or equivalent to 0. Only regions should be greater than or equivalent to 0. So these are nothing but. What are the only regions? These are the 3 only regions. So it is nothing but 45 plus X greater than or equivalent to 0. X is greater than or equivalent to minus 45. X is greater than or equivalent to 0. 10 plus X is greater than or equivalent to 0, which is X greater than or equivalent to minus 10. X cannot take negative value. So the minimum value of A intersection B intersection C here is 0. D is nothing but 0. Minimum only regions should be greater than or equivalent to 0. Maximum other than only regions will be greater than or equivalent to 0. Maximum means other than only regions will be greater than or equivalent to 0. What are the other than only regions? These are the 4 regions. 50 minus x greater than or equivalent to 0. X is less than or equivalent to 50. 40 minus x greater than or equivalent to 0. X is less than or equivalent to 40. X is less than or equivalent to 25. X is less than or equivalent to 30. X is less than or equivalent to 30. If I take 50, 40 minus 50, I will get a negative value. No. If I take 40, 30 minus 40 is a negative value. If I take x is less than or equivalent to 25, so it is nothing but positive, 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 25 minus 25. 30, 25 minus 30, it will be there. So what is the maximum value? Maximum value is nothing but 25. Maximum value is nothing but 25. I hope the idea it is clear. Maximum value is nothing but 25. All you have to do is just draw the diagrams for this and do it. 2 more problems, it will be extremely clear to you. All you have to do is how to plug in the values, you should know. And always remember, these regions cannot take negative values because it is a number of students. Minimum is only regions should be greater than or equivalent to 0. Maximum means other than only regions should be greater than or equivalent to 0. I hope the idea is clear. Then I will do the ANIL NAIR's approach after we solve one more problem. Second question, please take it. Second question, mu is nothing but 130. N of A is nothing but 80. Any student who want any help, please WhatsApp that number. Right after the class, I will try to help you. Shivangi Singh, please WhatsApp that number. Right after the class, I will take up, write anything that probably I can be of any help to you. Mu is 130, N of A 80, N of B will be 70, N of C will be 60, N of A intersection B, it is nothing but 30, B intersection C, which is nothing but 35, N of A intersection C, which is nothing but 40. We require A intersection B intersection C minimum, and we require A intersection B intersection C maximum, B intersection A intersection C maximum. I hope it is clear, right? Now if you see here, now is it clear? Now we will do 2 more questions. N of A union B union C minimum, N of A union B union C maximum, A union B union C maximum. Now see here, first we will draw the circles and we will find out the values, then we will do it. There are 3 sets, A is there, B is there and C is there. So these is nothing but, mu is nothing but 130, N of A is 80, N of B is 70, N of C is 60. N of A intersection B, A intersection B is nothing but, this is A, this is B and it is C, this is X. A intersection B is 30, 30 minus X. B intersection C is 35, 35 minus X. A intersection C is 40, 40 minus X. A is 80, 40 plus 30 is 70, leftover is 10. There are 2 negatives, so there will be 2 positives. 30 plus 35 is 65, this is 5. There are 2 negatives, so there will be x 2 positives. 40 plus 35 is 75. So there will be subtraction of 15. There will be 2 negatives, there will be positive. Now this entire circle value is nothing but 80. This entire circle value is 80. Total outside it is 130. 5 plus 35, 40. 40 minus 15, 25. 80 plus 25 is 105. Remaining is 25. I hope it is clear how am I doing. This entire thing is 80. 5 plus 35 is 40. 40 minus 15, it is 25. 25. 80 plus 25 is 105. There are 2 positives x. So there will be 2 negatives. 25 minus x. Now we will do intersection. A intersection B intersection C minimum. It is nothing but only regions should be greater than or equivalent to 0. Only regions are these 3 regions. X plus 10 greater than or equivalent to 0. X greater than or equivalent to minus 10. 5 plus x greater than or equivalent to 0. X is greater than or equivalent to minus 5. X minus 15 greater than or equivalent to 0. X is greater than or equivalent to 15. We should not get negative values. We should not get negative values. Minus 10 not possible. Minus 5 not possible. So A intersection B intersection C, it is nothing but minimum value is 15. Maximum is nothing but other than only regions should be greater than or equivalent to 0. 30 minus x greater than or equivalent to 0. X less than or equivalent to 30. 35 minus x greater than or equivalent to 0. X is less than or equivalent to 35. 25 minus x greater than or equivalent to 0. X is less than or equivalent to 25. 40 minus x greater than or equivalent to 0. X is less than or equivalent to 40. We should never get any negatives. 40 means 30 minus 40 negative. Again it is 30 means 25 minus 30 negative. 35 it is negative. So what is the maximum value? Maximum value is nothing but 25. I hope the idea is clear. 15 and 25. Praveen, I hope it is clear. Minimum means only regions should be greater than or equivalent to 0. Right? Maximum is other than only regions will be greater than or equivalent to 0. Just charging. Right? We will do one more question. Please write down one more examination original question. Then we will discuss the shortcut approach to find out the minimum value. Third question. Please write down the third question. Mu is nothing but 400. Okay, I think in this question, in the previous question, there are some more values. We have to find out n of A union B union C minimum, which is nothing but n of A plus n of B plus n of C plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Because it is plus sign, what if you want these minimum value, all these values are known to you, it is given in the question, substitute the minimum value here. If I want the maximum value here, whatever the maximum value that you got here, substitute there and you will get the answer. I hope the approach it is clear to you. I hope the approach is clear to you. N of A union B union C, minimum you can determine, A union B union C, maximum also you can determine. Third one, original management exam question with no change in values. Mu is nothing but 400. N of A is nothing but 200. N of B is nothing but 250. N of C is nothing but 150. n of A intersection B is nothing but 100. n of A intersection B is 100. n of B intersection C is 80. n of A intersection C is 120. n of A intersection B intersection C minimum we need to determine, and n of A intersection B intersection C maximum we have to determine. Right? Once you understand the approach, you can solve this question very easily. So these circle. Total mu is given as 400. These nothing but A is 200, B is 250, C is 150. This is nothing but X value. This X. A intersection B is 100. So 100 minus X. A intersection C is 120. 120 minus X. 100 plus 120, 220. Outside it is 200. Minus 20. Minus X 2 times. So it is plus X. B intersection C is 80. 80 minus X. 100 plus 80 is 180. So it is 70. Two negatives are there. So two positives should be there. 120 plus 80, 200. There will be 50 downfall. There are two negatives are there. So there will be X. Now outside value I require. Total this circle value is 150. Minus 20 plus 100, 80. 80 plus 70, 150. 150 plus 150, 300. This will be 100. There are two positives X. So there will be two negatives. So minimum value is nothing but only regions should be greater than or equivalent to 0. Minimum is only regions should be greater than or equivalent to 0. I erased. Just give me 1 minute, sir. Instead of eraser, I used eraser or entire slide. Just give me 1 minute. So these is nothing but 400. This is 200. This is 250 and it is 150. These is nothing but A. These is nothing but B. And it is nothing but C. These X. These is nothing but 100 minus X, B minus C, 80 minus C, A minus C, 120 minus X. 220 it is drop of minus 20 X, 180 it is 70 plus X, 200 it is drop of 50 X minus 50. Outside it will be, this entire value is 200, 70 plus 80, 150 minus 50, 100. 200 plus 100 is 300. There will be an extra 100. There is 2 plus X and there is 100 minus X. Only regions should be greater than or equivalent to 0. These is nothing but X minus 20 greater than or equivalent to 0. X is greater than or equivalent to 20. 70 plus X greater than or equivalent to 0. X is greater than or equivalent to minus 70. X minus 50 greater than or equivalent to 0. X is greater than or equivalent to 50. You should not get in the only regions negative values. This is a negative value and only regions 20 minus 50 is a negative. So minimum value answer is nothing but 50. Minimum value answer is nothing but 50. I want n of A intersection B intersection C maximum value. Maximum value is other than only regions we have to take. 1, 2, 3, 4. These 4 we have to take. So these nothing but 100 minus x greater than or equivalent to 0. These nothing but x less than or equivalent to 100, x less than or equivalent to 80, x less than or equivalent to 120, x less than or equivalent to 100. X less than or equivalent to 100. Now see, which one will give you negative value? 80 minus 100. No. Right intersection of all these we have to take. 80 minus 120. No. These also no. So A intersection B intersection C, maximum value it will be 80. Very time consuming process, very general traditional way of solving the question. Now we will see ANIL NAIR's way of solving the question. This traditional method, I hope it is clear. Now, ANIL NAIR's way of solving the question. How I solved this question? First, I will take question number 3. Let me take the values. Mu equivalent to 400. N of A is nothing but 200. N of B is nothing but 250. N of C is nothing but 150. N of A intersection B, it is nothing but 100. B intersection C, it is nothing but 80. A intersection C, it is nothing but 120. So I want N of A intersection B intersection C minimum. Whatever the concept that we did it in the previous type 1, we will do the reverse gear approach. We will do the reverse gear approach. What we did in the previous question, A is given, B is given, A intersection B, we disjointed the sets and we did it. Just to see here, assume this and this. What is the common value that is present in this and this? B. Compare it with B. 100 with 80. 180. 180 is less than 250. So the value can be 0. Next one. B intersection C, A intersection C. What is common in both of these? C is common in both of these. 120, 80, 200. Compare with this value. 250. How much it is more? 50 it is more. I hope it is clear. Then do this with this with this. If I do this A intersection B with A intersection C, what is there in the common both? A is nothing but 220 and you got 20. 0, 50 and 20 which we got. 0, 50 and 20 that we got. A intersection B intersection C. Just for our understanding, let us go back and see these diagram. These nothing but x. These nothing but 100 minus x. These I am going to use this one, sir. A, B and C. These nothing but 80 minus x. These nothing but 120 minus x. 100 plus 120, 220. 220 is x minus 20. Can I say that this is the value which we got? X minus 20 greater than or equivalent to 0. Are you all with me? Right? 180, 180. These nothing but 100 and these, where is B value? 180. 180 is nothing but 70 plus x. 70 plus x greater than or equivalent to 0. Minus 70 means lowest integer is 0. Are you all with me? That is what exactly I am doing. A intersection C, 200. C is minus 50. So minus 50. What exactly we got here? X minus 20 greater than or equivalent to 0. 70 plus x greater than or equivalent to 0. X minus 50 greater than or equivalent to 0. X greater than or equivalent to 50. This is the value. X greater than or equivalent to 20. This is the value. Because you got a negative value, you substitute that value. Now in this one, which value will satisfy this question? It cannot be negative. It cannot be negative. So if I take x is greater than or equivalent to 20, 20 minus 50 is minus 30. So find out this one and write down the maximum value of 0, 20 and 50 to get the answer. 0, 20 and 50, maximum value is nothing but 50. Maximum comes out to be the minimum because the value of these x should be greater than or equivalent to 0. That is the reason I took the maximum. Maximum happens to be the intersection of all these three values. I hope it is clear. Idea is clear. Minimum. Maximum, what is that we did? Here we got 100 minus x. If it is A intersection B, write down it as 100 minus x. Here it is 80. It is 80 minus x. Here it is 120. Here it is 120 minus x. Three cases anyway that you get. 100 minus x, 120 minus 80 minus x, 120 minus x. So put all of these. Take the converse of this. 100 minus x greater than or equivalent to 0, 80 minus x greater than or equivalent to 0, and 120 minus x greater than or equivalent to 0. Only thing which you need to do it is neither A, B, C nor D value. That if you substitute, that also do greater than or equivalent to 0. Take the intersection of all these values, you will get the answer. Please do not draw the diagram. Diagram probably could be drawn only for these values. Without a diagram also, you can solve it. I will do question number 2 and 1 in Anil Nair's way. Listen carefully, sir. Question number 2. What we did it in a traditional method, I will do it in an optimal method. Please write down the question number 2, which we solved it. You can cross check your answer. Mu is nothing but 130. N of A is nothing but 80. N of B is nothing but 70. N of C is nothing but 60. N of A intersection B, which is nothing but 30. B intersection C, which is nothing but 35. A intersection C, which is nothing but 40. I want A intersection B intersection C minimum. I want minimum. See here, sir. I want minimum. 30, 35. What is common here? B. 30, 35. Separate is 65. 65 is less than 70. So 1 is 0. Next, if I do this both, what is common here? C is common. 40, 35, 75. How much it is greater? 15 it is greater. Then do this first with third. What is common? A is common. 30, 40, which is nothing but 70. 70 is less than 80, again 0. Maximum of out of all these things. So answer is nothing but 15. Straightforward, without using the Venn diagram, you got these answer. Suppose if I want A intersection B intersection C maximum. If I want maximum, 30 means do the complement. 30 minus x greater than or equivalent to 0. This is nothing but 35 minus x greater than or equivalent to 0. These are nothing but 40 minus x greater than or equivalent to 0. Only thing, neither A, B, C nor D. Here only C values are there. So only what we require is it is 80. These A, B, C. A, B, C. What are all the values which we require? 35 minus x. These is nothing but x. This value we require, this value. Total is 130. So these is nothing but x. Here A intersection B is 30. 65 means it is 15 plus x. Here it will be A intersection C 40 minus x. 75. 75 means x minus 15. From here you will get the value 80, 15 plus 15. 115, it is 15, 15 minus x. So 15 minus x greater than or equivalent to 0. What is x less than or equivalent to 15 we got, 30 we got, 35 we got, 40. The value cannot take negative. Negative cannot be there. 40 will be smaller, 35 also. So answer is 15. I hope it is clear. I hope it is clear. If any calculation mistakes are there, please take care of itself. I hope you have understood the approach, right? In case if any calculation mistakes are there, please take care of it. Suppose minimum 0, 30, 35. I hope you have understood the approach. If any calculation mistakes, please take care of it. Let us do question number 1 also using this one. Question number 1. One is mu is nothing but 200. N of A is nothing but 120. N of B is nothing but 90. N of C is nothing but 75. N of A intersection B, which is nothing but 50. N of B intersection C, which is nothing but 40. N of A intersection C, which is nothing but 25. So N of A intersection B intersection C minimum, directly you can do it. A and B, what is common? B is common. 50, 40, 90. 90 is equivalent to 90. 0. Here what is common? C is common. 40, 25, 65 less than 75. 0. Next, what is common? A is common. 50, 25, 75. 0. So minimum value happens to be 0. I hope you have understood, right, how you can do it. Even you can also do A intersection B intersection C maximum. How you can do it? One is 50 minus x, another is 40 minus x, another is 25 minus x. Find out N of neither ABC nor D greater than or equivalent to 0. Do this and this and this and this greater than or equivalent to 0. You will get the maximum value. What is the difference between type 1 and type 2? Type 1, mu is given, ABC is given, neither AB nor C is given. But in type 2, mu is given, ABC is given, A intersection B, B intersection C, A intersection C is also given, N of ABC. This is type 1 and 2.